It's actually not that difficult, in my opinion. But you know, a lot of the tests you just have to review the specific information. Let me make sure I have my caption. Does that work now? No. Okay. All right. Share screen. Okay, so in this class, what we're gonna do is we are going to look at the overall solutions, right? Like in this class, I'm gonna train you how to be security consultant. So leaving this class, let's say if you want to take the certification, if you want to have your own type of consulting business, you can, but I would recommend that you get the experience in the field first. And so that way you can understand a lot more different solutions, because not all security solutions are the best solutions. They're just solutions that might work effectively for a specific organization. So the description is basically hitting the consultant area. You do see that there are a lot of jobs right now online remotely for cybersecurity consulting. So it is basically you are giving them your solutions or your ideas on how to fix or implement something, right? And that's what the consultant do. So that means that you have to evaluate the existing issues that they are facing, the problem, and coming up with the proper solutions for that specific organization. So in cybersecurity, we go through the life cycle very similar to software development life cycle. We go through the life cycle to really understand how we can derive a proper solution. So you will see some of this in the class. It also, if you want to do the ISC squared SSCP, which is a lot more money, I would only recommend this if a company is paying for you to do that, or somebody is sponsoring for you to do that, or if you are applying for IT management, security management, like, you know, if you're looking at IT manager, CIO, that type of position, usually they require CISSP. And then in order to update it, they make you pay a membership fee, which is also high, right? I applied before I came here, I applied to sit for the test, and that the highest level for this certification, it's the CISSP. That one you have to have 7+ years experience, and you have to have a recommendation from a person in the industry that holds that certification. I don't know if the same requirement is still now. Um, and it's $1,200, right? So I apply and I got accepted to sit for the test. And then I had changed my mind because I don't want that continuous cycle. So because I thought if I go and apply for a CIO job, I will probably likely get it. So I didn't seem like it's just not needed. But it's definitely something that you want to use to climb the ladder for cybersecurity. And then, you know, CSUSB, they support a lot of this in the upper division classes. I've seen some of that, and that can also be integrated in some internship, like with San Bernardino County, they provided access to preparation for this certification. Okay, so for this class, we're gonna meet once a week on Thursday in here for the semester. We are going to go through some of the enterprise level security. We'll talk about encryption. We'll talk about how we can overall look at security solutions. So a lot of the times you have to take something that's already in existence and redesign, right? Building from scratch is really easy, like a brand new company where you can place things a certain way, you can design solution, you can buy new products. Working with existing equipment and technology sometimes can hinder you know, how you approach a solution. So you have to have alternative ways. So we'll take a look at the requirements and how we'll be able to incorporate things like encryption in communication and data. We will take a look at how we can look at VLAN or virtual LAN starting today. Always start with network infrastructure design and redesign. So virtual LAN and how we can use that to determine vulnerabilities and segmentation. We'll take a look at how cloud computing and virtual machines and the virtualization area is really big in this industry. So I encourage you to learn a lot more about the virtual environment outside of the classroom. That's going to help you. So if you have exposure for that on the job, like if you use VMware, vSphere, or any other product like Hyper-V, you need to make sure that you put down the version number and the proper, type of virtualization that you're using. Also, cloud computing is important, like Azure, AWS, and so on, right? So having additional knowledge in that area is going to help you leverage how you're going to approach consulting and also your job in the future. We'll talk about enterprise storage down the line and, traditional SANs, network attached storage that's still being used pretty widely. And then we'll talk about virtual SAN, because most company would have data that's housed by the cloud company. So the data center would have these type of equipment. Our responsibility is to take a look at how the cloud company, secure their storage along with how the client is using the storage effectively and securely. So we'll talk about deduplication and multipath and, using snapshots in virtualizations and so on. And then today we'll start with infrastructure. And when you're looking at networking classes, a lot of the times it's just, you are exposed to network diagrams. But in this class, you are going to look at the higher level, right? It's not just one small network, but it's a lot of different type of network combined. So for example, if you're looking at a company like Walmart, Walmart is worldwide. And so we would take a look at how they are interconnected from their corporate office down to the regional level and down to the local level. So we have to look at how the network is designed and does it need to be redesigned. A lot of times we can't take things and move them in different area. Like I cannot take one location and put it in another city or put it in another location. I have to make sure that my network the design is working with the existing network, right? So sometimes we would throw security appliance on it and reconfigure, or we have to restructure some of the backbone systems to make sure that it is filtering and monitoring the right thing. So we'll touch a little bit on that today. We won't touch on voice over IP until later on, but this is also a critical area if they have a calling center like customer service where you can call 1-800 number. And so and also employee phone, all of that is now VoIP, right? Hello, how are you doing? Come on in. Long time no see.
Right.
And then on the physical network, so some of this is we're gonna come back to some of this when we're doing a project, right? My goal for this class is to give you an RFP. So basically when you're doing consulting, right, or you're working for a company, a security company, and they have you go out to do consulting, they usually tells you this is what the client network and infrastructure looks like, right? The building, how it's laid out. This is the network, how the systems are interconnected. This is the type of servers they have. This is the type of system and applications they have. Now you have a week to make sure that you close all the security gap or mitigate a lot of the threats or whatever, right? So you have to pull historical data and all of that. So sometimes you have to actually look at the physical building layout because physical security is also very important to us. Like somebody can burn the building down, right? We have earthquake and destroy our data center. So you will have to integrate that in the diagram. So for your project in this class, we'll touch a little bit on that later. You will have to incorporate a lot of these components. So you will respond to an RFP. So leaving this class, you're gonna have that on your portfolio, right? This class is, when I teach bachelor or master level, this is usually a capstone class, right? The master level, they have to do a lot more compliance writing, but in the bachelor level, they redesign and they give me, if I can still find some of my old student solutions, I'll bring it and share it with you. So we'll work throughout the semester, we'll work out some of the components and then we can incorporate that into our project. Any questions? Okay. So then we are gonna also take a look at the configuration for our communication system, which are our router switches and network devices. So as you can see, it really boils back down to network infrastructure, right? Like, this is why you have to be strong in networking and security. This is why you have to understand like the weaknesses in different areas of the network, and that's important. So we'll touch a little bit on DAM and SIEM today, and then a little bit on the switches and wireless security today. So then it breaks down to the host base, for the trusted host, the trusted model in cybersecurity, how we would be able to look at threats and, in vulnerability assessment, we take a look at how banners and things and data can be exfiltrated. So we would need to look at the operating environment. That means that how the users are using the data on the daily basis, how the systems are communicating on the daily basis, like your servers, your database, and so on. And then to be able to look at the sub area and close out some of the gaps. And then this is the area that I mostly operate in for now. So most of my clientele is requiring a lot of this because everybody is hosting web application elsewhere. And their main concern right now, as you know, is data leak, right? Because app can be installed on devices and then device have permissions, and then so app permissions and app permission control and all of that, app distribution and data access is essential. So we'll take a look at the weaknesses and the vulnerabilities in web application security and how to really overhaul and fix some of the area. And I think the other classes already touched on some of this. You've seen this before. And then, so we are going to have to use matrix, right? Matrices is used to score in security. Most IT manager, right, and security manager, they have to be able to assess or have some kind of reporting on how their systems are assessed. But it comes back down to vulnerability assessment and threat assessment, right? So the analyst, you could be the analyst, scan and perform evaluation of your systems, looking at historical data or current logs, and be able to derive some kind of data sets for the management people, right? And then we would be able to take that and put that into matrices to be able to do cross analysis on, would be relevant and needs to be addressed now, that's critical, and what is not as critical. So we would go through and do measurement on different various level. I think we touched a little bit of that on CIS41A. However, you do see some of this. So in various lab, we'll do some hands-on. I think if you haven't seen these before, right, you can also take ethical hacking classes that's also address this in 41A, but we'll revisit some of this. And then risk assessment, we touch a little bit on matrices, and then it comes back down to following the rules, compliance, making sure that we're not out of compliant for local, regional, state, and federal, even national or international level, depending on your organization. And then a little bit of forensics. So this class encapsulates all the other components from the other class, as you can see, right? On how to look at forensic processes in incident response and security measure. Hi, how are you doing? And then this is usually the least of all my technical students is policies. But a lot of times when you come in as an intern, apprentice, a specialist, sometimes they make you sit down and write these because, the technical people, they don't like to do the writing, but it's actually easy work. So let's say that you're a consultant for company ABC. They already have a set of policies, right? After you do the analysis and evaluation, you saw some issues with their policy. For example, right? Data retention, or data protection type of policy. They're not doing as well in that area for HIPAA compliant. Then you have to take a look at how they write their policy and how the policy is applied to system configuration, and then be able to update or improve the policy. When you do that, and they should, by requirement, they need to regularly revisit the policy, not just one time, right? They have to do that annually for various compliant body, and then to be able to support their operation. So once you rewrite the policy, you would then update, and we normally update the IT team, the security team, and then the users, and then we train the users on how the policy is effective. Because if you're implementing software or practices, you have to make sure you train them, right? Otherwise, people won't be able to access their things, and then it creates issue for support and services. So all of these acronyms we're going to talk about, right? In the upper division classes, so I will require you to write some of these for your project, and I will give you templates to do that. So leaving this class, I know that we only did like maybe a couple policies in various classes, but we want to make sure that we know how to do a lot of these when we leave the program. So here's your learning outcome. Making sure that you assess the gaps in existing enterprises for these areas. Okay. And then we want to always address CIA in cybersecurity. And then we want to know how to implement and deploy solutions based on SDLC. Okay. And then making sure that we know how to prevent or detect issues in our system. So this is just a larger scale, right? From 27 or 41A. Okay, any question? So this is the book I'm using. It's actually not a bad book. It's a decent book. If you have PACT membership, you have access to unlimited books if you pay like an annual fee. So I pay $100. I have access to unlimited books and videos by PACT. It's great. They have a bunch of stuff from different certifications to machine learning to data analysis, whatever, right? I went through about 6-7 books during the summer to kind of look at which one would be more effective for this class. And I felt like this one is probably best. Publisher offered quite a few books to me for free to teach for this class. But, and when you look on Amazon, there are some of them. This certification is not that popular, so you don't see as many books on Amazon for this particular certification. They have the older version as well. So this is one of the newer version of it. So I chose this book because, it's easy to read. And if you have PACT access, you can also watch the video, very similar to Test Out. But it doesn't require like a lot of like the Test Out tasks. I do take late assignments. The policies are here. I think most of you had my class before. 10% deduction for 1 week late. Subsequent week will be 20%, and then 3 will be 30%. And I like not to take anything after that. But if you run into issues or have problems with catching up with the assignment, just let me know. We'll work out something. We'll do some in-class assignments and some hands-on activity every time that we come. If you have unfinished, or sometime I would assign things outside of class, you can do that outside of class, and that will be the hybrid portion. And then we would do some projects. So in this class, we will build a project for security solutions. I will release a project probably, I want to say after Thanksgiving. That gives you time to not think about the project and then relax for Thanksgiving and then come back. We will work on the project. This book in particular have breakdown of about 16 chapters. So there are times that we're gonna couple up some of the chapters at the end. I think I put down the schedule in Canvas in the first module. So I like for you to work on your project sometimes throughout the semester. We will work in teams because I really feel that it would not be fair for you to derive a security solution on your own for this scale by yourself, right? So if you really determined to do it by yourself, I would say have at it. It's gonna be really difficult. So we can work together in a small team and you can divvy up the task. And then we can work throughout, but make sure that we plan our schedule and do time management. Every single class I address this, right? But we always have students that wait till the finals week or the week that it's due 2 days before and try to start the project. Let's not do that, right? So I'll remind you to start your project, right? So today, after today, we're gonna think about like how we're gonna redesign a network layout, and implement security appliances on our network layout. Okay. We will have various quizzes. There are 2 quizzes in this class and 1 final exam. I will write the final exam to the practice exam for the certification. Unfortunately, we don't have a free practice exam tool, but you can find other tools available online or books that will help, even our textbook. If you get the textbook, at the end of each chapter, there's practice questions, and then at the end of the book, it has the practice exam. So you can use it. And it has the solution if you need to look it up. Okay. I'm not sure if I want to use Lockdown Browser anymore. I had some student that used Linux system and they did not have success with Lockdown Browser. So let me think about it. All right, we'll have some extra credit. It will never exceed 10%. Normally it range like 5%. So it help lift your grade if you're at the border, right? If you're already at 99%, you will finish out with 100. There's no additional percentage that I can give you. A lot of the students are A students. They do a lot of extra credit and it might lift a few percentage, but I can only give you a letter grade with no pluses or minus in this district. So you will, the range is listed here. So your project is going to be 15% of your grade. Quizzes will be 10%. Assignment and participation will be 35%. Your lab exercises will be 20%. Your final exam will be 20%. Okay, any questions? Okay. So if you are missing for a long time and don't show up to class or submit any work, and I don't get any email or notifications, I do reserve the right to drop the student. If you wish to drop the class, make sure that you're mindful of, right, the drop deadline, because your financial aid, if you were receiving financial aid or paying for your college, will be impacted because it impacts your finance. So if someone is missing 2-3 weeks in a row, I do reserve the right to drop the student. Sometimes in the case that I don't drop the student will receive the grade that's earned in the class, and usually it's not high. If we have any kind of issues, please address it with me. But make sure that if you are using internet resources, including AI, right, make sure that we included the resources in citations, because you don't want to show employers, and then if you plagiarize a bunch of things from, organizations like policies that you copy and paste from somewhere, that's not going to look good for you, and it won't look good for the program and other students in the program. So let's try to make sure that we do our own work. We can use the template and we can document the we can cite the sources for the template. They actually changed the accessibility center. They're calling it Accessibility Resource Center now, which is a really nice name. So you can visit their website. They have drop-in Zoom hours and phone number that you can contact. So if you need accommodation like extended test time, or any kind of technology that they can help, make sure that you communicate with them. Okay. And here's my contact information.
Where was that picture taken?
It was at one of the garden in San Diego. I just like unicorns, so. All right. I think, so if you call this number, likely that you will hit my voicemail. Only when I'm in my office, I can answer that. And usually that's often Friday. Even for office hours, I like to come in here before class until we move this classroom, right? Then my office is now in Science Technology Building, first floor. When you walk through the Makerspace Center, I'm right in the front, right? With the office, I'm on the left side. So I took the corner office. It's nice, but smaller. So usually I'm there when I have events and things, or on Friday, I'm here for other activities and requirement. So I do hold Zoom and physical office hours. So if you need help with catching up with lab or have questions, you can come in before class, or we can make an appointment. So Monday and Wednesday, 3:30 to 5, Tuesday. Usually I have committee meetings on so often on Tuesday. So I do virtual. So I might not be on campus for 4 to 5, but if I happen to be here for the meeting, if you need to meet in person, let me know. And then on Thursday before class. I have a couple appointments tomorrow. So some students online, they wanted to ask questions. So you're welcome to send me an email. All right, any questions? Okay. No questions. That's good. So all of this information you can find here. Your weekly schedule is listed there, and it's tentative. Okay. So let's download the notes for today. I know it's lengthy, right? The higher classes, you're going to see that there's a lot more information. But a lot of this is review for most of you, because you've taken the classes. And if you need a USB, there's some USB up front to save your work to take with you. Remove the zoom bar. And let me zoom in. Use navigation bar for a second. So after the assignment, we'll take a short break because I know they close the restroom after a certain point. They do that now? They've been, yeah. So if you need to use the restroom, we can do that and get some snacks, and then we'll come back and do the lab. It's light today. Okay, so today we're going to talk about securing network architecture. There's a lot that goes into it, right? But if you are a network engineer or a security network engineer, you have to work closely in this area. But as a consultant, a lot of times we have an external perspective on how the network should be redesigned or certain implementation needs to go in place. But by practice, there are specific things that needs to be there. So when you assess the network, if it's missing, right, you should have your checklist. You should say, okay, this is missing, or this could be implemented to improve your network throughput and security. So having an understanding of the OSI model is really important, right? Because it really pertains to how system communicates from the low level to the higher level, from your physical all the way to the application. And we can assess the vulnerability at different layers, right? In the physical area, someone can just pull a cable off of your systems and disconnect it, right? And then in the data link, that's where the switch happens. So if you understand the protocol and the appliances in each of the layer, that's really essential. I've had a few apprentices or students that are in the apprenticeship program fail to answer this question with employers. They would ask questions like, can you describe the type of systems that are in the OSI layers or the protocol? So make sure we understand and we know the OSI layers well and what goes into each layer. So MAC addressing happens here. Someone can spoof the MAC address and become a trusted system, a trusted host in that segment, right? Especially for the wireless side. Wireless, you still have the OSI layer. OSI layer is really designed to do what? To standardize how vendor builds the systems that communicates, right? So if you buy a certain brand of router, it's still going to work with specific protocol. So it is a way that the industry agreed upon to make sure that UDP is for transport, right? And TCP is also for transport, but it has more confirmation. So whenever that you see UDP and TCP, that's always for transport. Think about moving packets, right? And then for the session, this is when you log in, when the user, after the application, they use the browser, they authenticate, that session is created, right? You guys hear about session hijack. So in that case, what we see is we do see services and protocol that happens in every layer. So when you assess for vulnerabilities, you need to take a look at these areas. And then at the higher level, especially with the interfacing the user, you see the application and how data is presented to the actual application itself is the presentation. So encryption and decryption happens here, right? And that's really simple. So if encryption is jeopardized, a lot of the times you need to assess this area. So data encoding, encryption happens there. And for example, I open a web page, it's written in HTML, right? And we would look at how the program, which is the application, interpret what the content and even the data from that website. Let's say that if you're downloading a PDF from that particular web page, right? So presentation and application. So make sure we know this well. Okay, so let's go through. Sorry, let me get my version. So for the first question, it asks you, why is OSI model important in network architecture security? Because each layer in the model contains vulnerability, right? And we need to mitigate those vulnerability with appropriate design, configuration, and practices. Sometimes we can rewire the cable. Sometimes we can configure something to protect that particular layer. Or sometimes when you're looking at routing or switching, right? Like for MAC address, we can look at MAC filter. For IP, we can implement firewall for IP filtering and so on. So it really depends, right? So in general, we need to understand what's happening at each layer in the OSI model to really assess specific vulnerability for that area. Now, some company, they would use something called Unified Threat Management, or UTM. This is an all-in-one system, and it can be implemented as hardware or software. A lot of times when you see security appliance in the industry, it's usually, there are two options, right? We can implement the software tool or we can implement the hardware tool. A lot of security people, right? Some security appliances is more advanced in as a physical system. However, because it is a computer, you have to configure it, right? You have to manage it, you have to maintain it. And the software level, you can install that on your existing system and be able to utilize it or interface with it, but you still need to configure it. So a UTM solution is an all-in-one appliance or software that is used to protect the entire network. It is exactly what it's called. It is a way that we can detect threat, manage threat, control the security in our architecture by implementing specific practices and rules. Now, when it's used in a small organization, small scale organization with limited resource, it is more ideal. Think of it like you don't want to buy 5 different appliances, right? You just want to buy one and you just want to configure that one. So it's streamlined management for the smaller company because they might not have the people to be able to manage it. Now, on the large scale enterprises, when we're talking about worldwide corporations or companies that have many, many different systems and users, it will not be ideal because it becomes a single point failure. So a lot of the things that we do in security, our solution, it depends, right? When you're looking at the scale and how it's used for operation, it might be ideal for one, but not for the other. So there's no 100% guarantee in anything. So we might implement UTM 1 year and then we might grow very quickly as a company and it might not work in the next 3 years. So you have to look at how you're scaling as a company and what your existing system is able to do. Any question with UTM? Now, in the notes, that section, it talks about the advantages and disadvantages of UTM. So how should it be used, right? In general, UTM should be used to really reduce a lot of the management effort, the hours that you need to put in to manage 5 systems, right? So let's say that I want to implement 5 different security appliances. I need to configure 5 of them and I need to manage 5 of them. That can be a lot for a small team. It also reduced costs because it lessened the hours that goes into management and the hardware or the security appliance that they need to buy. And as you know, security appliances can be very expensive. So it really helped reducing the management effort and it lessened the need for appliances, which ultimately reduce costs for us. When shouldn't they use UTM? When it becomes a centralized risk, because attackers and when you see external threat coming in, a lot of times they're going to focus on a target. And when it becomes a single point failure, they can just attack that target and take that down and expose your network completely. It also creates bottleneck where everything is filtered to that one location that reduces your network throughput. So think of it like if you're having 5 doors, we're going to funnel it to 1 door and that door filters everything. Sorry, it becomes a problem. Yeah. Any question? So anytime in network or security area, if you having a centralized system, the next thing that you need to think about is single point failure, right? But we can have a centralized system, but if we have backups, failover, if we have alternative ways to diversify, right, our network throughput, then we might have a feasible solution. But when you're looking at like corporate environment, a lot of the time everything is controlled through headquarter office, right? And that becomes the centralized area because that's where all the management happens. For example, case in point, RCCD. Everything is controlled by our district, right? All the networks from 3 colleges funnel back to, even our backbone here, funnel back to RCCD network. There are people up there managing the network and the systems. And, you know, even if they have data center and cloud for various areas, right? It becomes highly targeted in that one area, right? So they have to beef up their security for that centralized location. Even physical security, right? You can't even take the elevator up without having the proper badge and ID and checking in at the front desk. So it's important. And you see that with all organizations. Okay. So here is a picture. So you see the router, right? This is gonna pass our traffic. We have to get used to looking at this, right? And then there's your firewall. So on a rack, simply, you have a router system, right? That's connected to who? To what? Your router is connected to what? Internet service provider. Thank you. Likely your fiber line, right? Your fiber box. So you would have a line in, and sometimes that could be, you know, on the small scale, that's just an Ethernet, right? But let's say that we have a larger network now, enterprise internet service provider. Then your firewall is attached to an appliance, so it's connected to UTM. Why is it so? It's because that way when things are passed through here, it's doing the filter, it's feeding the information to the UTM system. And the UTM system, you can also configure a rule for threat intelligence and blocking threat. But the firewall's job is to do what? Allow or disallow, right? That's what the firewall does. For most of the firewall, whether it's looking at packets or, you know, it depends on the type of firewall. We'll get to that. Then we have web application firewall, and this is for the website. So most company would have a database attached to an application. So for example, if it's a gaming company, you know, gaming app attached to user accounts which exists on a database. So this firewall job is to protect the web application, and this is for the DMZ side. Then we have a proxy. This is for the DLP, this is for data. And then, you know, we can also implement antivirus. So that means that we want to make sure that our systems are protected as a network, not just on a single host, right? And so on. So as you can see, there are different roles that can be integrated, and then your internet service provider is connected. So this diagram is somewhat misleading, but yeah, it can be. So we want to connect it to the router, your edge router. Anything coming in from other network, your edge router handles. Sometimes they would have an outer firewall, so your border firewall would be connected before it hits the router. So it really depends. But on this diagram, it shows it as a centralized system. So if I am the attacker, where can I get access to the others. This, right? UTM is my focal point. Any questions? Okay, so now, let's go to the next part. So for the majority of the time, the security appliance that you see in enterprise network protection is going to be NIPS, NIPS, Network Intrusion Prevention System. It detects and prevents. Now, in some cases on the legacy network, they might have NIDS, which is NIDS, Network Intrusion Detection System. Those system only sends out the alarm, but it doesn't prevent, right? So the majority of the time you would see the NIPS would be integrated. So before we answer 5, let's take a look at how that is. Okay. Now, so you have internet service coming in to your router. This is going to get routed to specific segment of your network, which is to the switch. Here we would implement a firewall to filter, right? And we would implement the NIBs. So on the rack, all of these systems are together, right? Physically, they're together for your backbone. And so, and then this is going to be for the larger switch that's going to be distributed to the smaller segment, of course. So here you would see that you can implement NIPS. Okay, so we would connect it logically the way it's laid out logically on for this particular organization. It's after the firewall. Often that you would see this more deeper inside the network, right? Or some cases in after you get through all of the filtering system for, you know, for the inbound and outbound traffic. We don't want to put it out here because it defeats the purpose of detecting issues in our network. We want it, it's an alarm and prevention system for our internal network. So you want it to be inside your network, okay? So it provides a lot of all the security appliances. It tells you some kind of compromises or threats. So indicators of compromises, and you see this term on a lot of different certification exam. That is often just irregular traffic that could be harmful, right? Something that's out of the ordinary, like denial of service attack, you're gonna get floods of a bunch of, you know, different type of, or the same type of traffic coming in and targeting that one single IP address. Now they're able to do a group of IP addresses, you know, but with that, you have to have many systems. So you have to have a lot of different systems that we use as zombies to do that. Or sometime that we can use IOC to look for as an indicator for malware. Malicious payloads simply it's just data that's malicious, and malware is notorious for that, right? That's mostly malware. So you might have an attachment, an executable that's downloaded, things that are being passed through that could be harmful to a host or your network. So for 5, it says, what type of information can be discovered from IOCs? Attacks, such as DDoS or DOS, and malicious payloads. Now, unlike prevention system, intrusion detection system only is an alarm system. It tells you, right, there is an intrusion. In IDS, when it's implemented, usually if you're implementing the traditional IDS, which is signature based, signature based is it's only referencing the database of signature of what is a threat and what is not a threat. So though if the rules are not set or the signatures are not found, it wouldn't simply ignore it, right? So I just installed security camera, again, a different set on at my house. And you know, on the security camera now, it's really using a lot of artificial intelligence to really detect like who is a familiar face, right? So if you train it and teach it, now if I don't tell it a familiar face, then everybody is a stranger, so it's gonna continue to notify. So signature based is like that. You have to continue to feed it the signature that it needs. So that means that the maintenance and the management aspect of it is required. On the anomaly based or heuristic based, it's a little bit more based on what is normal. So that means that we have to have existing data in the network or our enterprise to say that this is the baseline or this is the norm. Anything outside of this scope is irregular and it needs to be alarmed. Okay. So anomaly-based or heuristic-based IDS should be implemented for enterprise network. Why? It's because it compares the definition to what's normal. And if there's significant deviation, so for example, my normal traffic is pretty steady, and then I get a flood of traffic for denial of service, then it will sound off, right? Because it compares it to what is normal in my network for throughput. And that could be data oriented, or sometimes that could be, you know, specific services and protocol oriented. It is effective when you are identifying unknown threats. So in enterprises, often that we want to detect things that might not be known to us. Because a lot of the things that known to us, some of the other security appliances that you implemented will likely pick that up, but heuristic based for IDS is ideal. So when you're using a NIDS, right, make sure that this area is addressed. Let's say that you go into a company and they're using signature-based network intrusion detection. You can't tell them, rip it out and put a new one in there. They're going to ask you justify how and why, right? Like, why do you want to buy a new system and put it in there in place? It's working. So the way that you back it up is if you're looking at the data, how effective it is. If it is really poorly performing, then we probably have to replace it. But if it is working, right, you have to make sure that we implement solutions to maintain it over time, making sure that it has the proper signature. So where can you get those signatures?
The vendors actually have data every.
Yeah, and if they don't, right, if you run into issue, if you find something new, because they don't always have the latest patches, right? Or the latest signature for things, then you need to notify them, right? Sometimes they even offer services where you can pay to customize for your needs, right? Now I think there's a lot of individualized type of environment for the operation with the extra money. So for NIDS, for network intrusion detection system, it should be implemented in the enterprise using port mirroring. Right? You see this with switches and even spanning for NIDS to monitor network traffic. Port mirroring is often used for monitoring because it's able to capture, right, what's being passed to a specific port. So in the case that that is lacking, if they're not doing monitoring for at that level, then you have to provide the solution or recommendation that they would need to reconfigure their appliance to be able to monitor. So here, this is the diagram for using network intrusion detection system. You notice that in the other diagram for the NIPS, it's before the switch, right? So for the alarm system, you tend to see it deeper inside the network after the switch. Okay? That's the recommended industry placement. Is it always the case? No, not necessarily, but does it make sense? The alarm system for the network should be inside the network more, right? The prevention system might be a little bit further closer to the edge of the network. Compare because you want it to really prevent things from entering the network. It's like, we don't build a fence inside the house, right? Or a gate inside the house. So think of the prevention system are like our gates. It's outside the house, okay? Inside the house, you might have surveillance camera because it's an alarm system that will tell you someone strange is coming in your house. So NIDS is that alarm system. All right, next we're gonna talk about wireless. So for the wireless side, wireless prevention system is part of the network. It's just focused specifically for the wireless. So your WIPS, your wireless intrusion prevention system, it should be implemented for the purpose to detect rogue APs. How can a network have a rogue AP? A user can bring their home router from home, come to work, plug it into the jack that has Ethernet connection, and that becomes a rogue AP. Someone can also create an evil twin using something like Wi-Fi pineapple, right? So rogue APs can create problems in your network because it's misconfigured or not properly configured. It should not be there, right? Other things could be attached to it that could be malicious. So we want to take out the rogue APs. So WIPS is good for that. It's also good for misconfigured wireless system. Could be outdated in configuration. Things that people bring in from home, bring your own devices becomes an issue, right? So that really reduce the level of risk that we would be facing if we implement this. This is specifically for wireless. Now, how is it implemented? It should be implemented in line with the wireless segment. So that means that as it comes into your wireless router, right, or your access point, it should be in line together with your wireless access. So most of the company, the wireless segment is isolated, right? It's not, it is part of the network, but you want to segment it so different IP addresses, it's still being routed into the network because we can control that. And a lot of times they set it up with virtual LAN. So that way when we filter, we know exactly the type of traffic that's coming in that's wireless and the type of traffic that's not wireless. Understand? So when you're looking at like public based wireless like this at RCCD, that can be placed on a VLAN, and we just control that port on the VLAN. We mirror that port and we monitor that port, right? And when you set up the WIPs, you can detect right away. I've seen people plug their routers here. Okay. You know, to the network connection. When you turn on a router, nothing happens. It's just local, right? But when you connect that Ethernet cable to where it says internet and connect it to the Ethernet connection, now it becomes part of the network. It's going to obtain an IP address. It's going to broadcast. Other people are going to connect to it and then connect it to the network. If you don't, let's say that we have no security on that wireless router, it becomes a problem. Okay. But if you have thousands of network segments, you're not going to be able to determine, you can't go from one to one to check. So you're going to use a system to sound off an alarm and just kick it out, right? It's going to say, oh, unknown device at this IP address, block, boom, but it logs it. And it tells you exactly the location on the logical network. It's going to say, oh, it's at NBC, so-and-so office. Any question on WIPs?
You said Wi-Fi pineapple earlier, right?
Yeah, Wi-Fi Pineapple is a device that they sell on Hack5 that you can make a mimic or a look-alike of your home router. So I have it actually in my car. It looks like a router. You just use a power bank. It runs embedded Linux, very similar to Kali Linux. The system comes equipped with those software packages. So when you start it, it boots Linux. It's all terminal, so you just execute. And what it does is it looks for access point around it, and it's gonna mimic it. Eventually, so the Evil Twin is the one that lures other people to it. So you can use it to get people's passwords. So let's say that I run that in my car here now. Someone comes to the campus. They see, oh, RCCD access point, connects to it, logs in, right? Yeah, I can run, keylogger and stuff in the back. I capture, or I can also sniff out their password, capture the information, and that's the Evil Twin effect. And the cool thing with Wi-Fi Pineapple, they made it where it's very easy. If you want to practice, you can kick it out, you can kick people out. So you just one button, you just click it. And then, so you can select the system. So if I want to wipe out someone, and then eventually I can eventually wipe out some of the other systems. And there are other functionality and tools with it. So basically it has exploitation, programs or applications that's already integrated. And tutorial for it is really easy to follow. It runs about, I don't know the small one, they used to have it for $60, but I think now it's 100 and up. The ones with a lot or more antennas, you can go further in range. So it is kind of dangerous, right? Like someone can sit in their car with their power bank and their laptop and can be doing that. So that's why public Wi-Fi should never, it's not safe. Okay. Yeah. So these are some of the threat issues that it can be addressed. I thought that this is cool that the book mentioned the encryptor. You don't see a lot of this in most of the network environment. I guess some area with high level of need for encryption like this, you would see an actual appliance. We tend to use more software based. So this is an example of tap lane, which is used by our government, by DoD, for a specific reason, because if they need to have high encryption communication, things like that, you would see an appliance like this. But you don't often see this in private sector and regular networks. But if you come across it, this is what it's used for. So this is a military grade one, right? And it's required for compliance reason. That's why they have to get it. But often you don't see that. we normally use like encryption that's already equipped with services like VPN for that. Or even on the user side, you use VPN to connect remotely or to your system. That tends to already fulfill a lot of the compliance need for regular companies. All right. So now coming back to here. Let's talk about network access control, NAC, right? This encompasses a lot of different areas. And you don't have to put, I mistyped that. So the security measures, I think in the notes, it doesn't really spell out specifically in this verbatim, but if you go through it in each section, you can summarize some of it. Describe the type of security measures that can be implemented in an enterprise network for network access control, right? VPN for remote access, that's important. With VPN, we can encrypt the traffic so that way it's not fully exposed, and be sniffed. We can also implement VLAN segmentation, but VLAN does have flaws, so VLANs is not always 100% good solution, but having it is a different layer. We can centralize network access control server to really determine how our network access performance or health is. And if you look at the diagram in the notes, it shows the NAC server as a health server. So it does the monitoring, keep logs. It's able to provide you the status of your systems. Encryption is always important if it's already not used in VPN, encryption in communication and data for data access. And then there's a huge section on authentication. But with multi-factor, I think that's a base requirement these days. But authentication is an area that's very huge. You have to take a look at the protocol that's used for authentication. So for example, when you guys are logging into your RCCD account, right, you're logging into Active Directory user account, okay? And that uses MS Chat with lightweight, right? Now, if they're implemented EAP or different type of EAP, so different protocol is tied to different type of encryption for authentication, and that can either reduce or heighten the vulnerability for authentication. The term multi-factor, right, is kind of clumping up everybody. When they're implementing a multi-factor, it doesn't mean that they're 100% foolproof or safe, right? Yeah, it is an elevated level when someone cannot impersonate you. However, the point between your system sending the request to the authentication system and it's responding, right, that transaction right there is very important. If it's not properly encrypted, that can be captured, right? You already know session hijack is all about that, okay? But in authentication, we have to take a look at how the servers are communicating with the client that's requesting and how that server is protecting the authentication or the security token for that particular user. So remote access falls down if authentication falls down, okay? So whenever I evaluate authentication, I always come back and ask them, do you have an RIS? What are you using for your remote access? What kind of authentication are you implementing for that? Because a lot of the time they centralize authentication back to Active Directory. They implemented that for all, other area like web application access, database access, and so on. And then you're controlling the permission and the privileges in Active Directory. But you also have to take a look at how the communication and the encryption is used across these areas. So knowing that's important. And then for your SIEM, this is focused on user management, okay? And SIEM is good for that. It is good for other things. I know that the other class addressed that, or it talks about oh, this is the system that manage your events and all of that. It's good for incident response. It's good for user account management, especially if you have like cloud-based or large-scale users. Think of like TikTok, Facebook, you know, you must have some kind of centralized management system to really logs incidents and things. So SIEM is needed for that, right? And the list could expand. So these are some of the general requirement that we should look at. So what am I giving you here is a checklist, a roadmap on how to assess network infrastructure. So as you go through, you ask yourself, is this there, right? Does this exist? Is it properly configured? If it's not, right, fix this. That's your solution, okay? So the role for SIEM, as I mentioned before, is a way that we can correlate and normalize context of alerting, and you can grab this from the note, providing reports and alert based on real-time log data inputs. So it's good at providing you the alarm, what's being alarmed, how it's associated with certain type of event that happens on your network or your system. So it's good for monitoring, especially if you have a very large user base. It's also good for building threat intelligence. So threat intelligence is just a database or a list of what are the threats, who are the threats. And we can use that to feed into our other security systems to say, this IP address is malicious, block for the firewall, right? This MAC address is malicious, block. So building threat intelligence is to pull the data from SIEM that's going to give you more detection and prevention. And it's ideal for incident response because it is an alarm system. You can also set it to block and prevent and things like that, right? We have to configure the SIEM. Question? Okay. So here's the diagram that I referenced earlier, right? Your VPN connection. So when I work as a remote worker, which is very popular now, I connect to the VPN server, or if you're using VPN service, that's the same thing. It passes through the firewall to check my connection if it's safe or not. Then it goes into here, then your NAC health server is gonna check. But when it goes to the firewall, it's gonna verify, okay? And if it's not, it won't allow it past this point, okay? But we omitted the routers here. And then if I need to access internet service, what could be internet service? Well, the companies might offer things like, I don't know, in some kind of subscription to a certain service within, then they might have an intranet here. So when we're looking at this, right? Earlier we talked about the UTN. In this one, we can also look at the SIEM as a centralized system. So web application firewall feeds into this. Our regular firewall feeds into this. Any kind of logs that happens for the other system, it goes into this because this system, remember that this is for data purposes, right? Building out more information about threats and vulnerability, okay? So your appliances and your connection, your communication system feeds into this. So the logs get forwarded into SIEM, and that's data, your pieces of data. And then it becomes a centralized system to really determine, oh, is this functioning properly? Is this functioning properly? Is this doing its job? Right? So that's going to give you an overall picture, because your network could be thousands and thousands of systems and network segments, right? Very large. So this is a dashboard by AT&T. It looks like this. Mostly user friendly. And then it has a lot of functionality for data analysis within. You can pull reports. And then now they're integrating machine learning and other things. So, okay. The following part talks about switches. I think we touched a little bit on that when it's handling layer 2 for MAC addresses. You would be able to get work with ARP, but sometimes if you have like looping issues that might cause performance degradation. And then depending on the type of switches, sometimes you would have the higher layer switches, like layer 4 switches that's used for void, or it would be used for other things. So you have additional protocol that's integrated. It's an example of your switch configuration, right? If you have taken routing and switching over the summer, you've seen this, or other classes for Cisco. So it normally gives you like the network information, the addresses, the type, and the ports that's used, the physical port. There's your firewall. So let's touch a little bit on this. Hardware firewalls is a very common thing in a security environment. You would see appliances that's being used. Sometimes they also implemented software firewall. You see this more for, you know, smaller scale home use space. And then they can also implement virtual firewall, which are appliances that run as like a virtual machine that has firewall capability. So this is like a computer that virtualized as a firewall, right? Think of it that way. Now, here are some of the terminology that you will see in certification. Your first generation firewall, those are the more traditional, right? Packet filtering is one of them. That's very, very popular. It basically look at the IP addresses, where it's from, where it's going to, what port it's using, block, allow, right? That's your first generation. This usually is for high performance reason. Now, some router can be a filter. Your wireless router at home can act like this. When you set up your port and IP filter configuration on your router, that becomes a packet filtering firewall, right? So router comes equipped with this for most part. The second generation firewall, it does filtering for the packet level as well, but it does stateful inspection, okay? And so that means that it's looking at more specifically the service and the protocol, where it's going to and which ports. So it is a little bit more elevated for the second generation firewall, stateful inspection. Now, more modern networks, most of the more modern networking would see next generation firewall. This is multifunctional firewall, right? It's able to handle other things, but it's not the same as your UTM, okay? Now, different level in filtering, also cost and management capability. So we should be able to answer that question 11. For the large network, what type of firewall generally yields high performance? What type of firewall provides multifunctional security control? So the first generation firewall, such as the packet filtering firewall, in general. But if you have one firewall and all of these traffic funnel back to that firewall, like that one screen door. So let's say that you send 100 people from 100 rooms to that one door, and every time that they pass through that door, you have to have it checked. It's gonna slow down, right? The line is gonna get longer and longer, and it's gonna take a long time. So that can also create bottlenecks. So high performance in general, if it's properly configured and designed in the network or implemented in the network, I should say, your next generation firewall gives you multifunctional security control. So that elevates the level of filtering with additional features. That's all that is, right? Questions? Okay, so next is gonna be routing. So for the routing table, when you're looking at a routing table, it's gonna look like this. It's gonna tell you where it's going to, right? Net mask, we talked about this before. That's like the zip code or the zone that needs to get to the network. The gateway, which router, the interface, and then the metric. You guys know what this number is for? What's the difference between a 20 and a 30? Anybody took, if you took my 40B last semester, you should know this. What's the difference between a 20 and a 30?
Is it the VLAN or
I'm sorry?
is it the VLAN?
No. Well, VLAN is for the switch level, but for routing. So I'm gonna give you an analogy. You go on Google Maps and you put in an address like MVC from your home, right? It's gonna give you 3 routes. How to get there, right? One route is gonna be, let's say, 3.5 miles, 5 minutes drive. The other route is gonna be 5.7 miles, 8 minutes drive, right? And then another route, right? Longer, 10 minutes drive, right? So this indicator, there are values on how the router can determine where to pass and what to pass, right? It's a value, a matrix it's usually use this to determine which router it sends to, okay? Now depends on the type of protocol that's used. So we'll touch a little bit on that next. Now, on the routing table, if I put in a static route, I basically said, I don't care how how many routes, right? I'm only going to drive that one road, that one route to school every single day, right? So you basically program in and say, from point A to point B, take this route. From point B to point C, take this route, right? So static routing is about setting up the same route for those from point A to point B, okay? And you would have to list that here. Now, when do they use that? When there's specific type of requirement for communication, right? We don't want it to send to other systems that's autonomous. For example, Department of Defense might only have that one specific route for a certain special high clearance data to be sent, right? So they would set up the static routing. Dynamic routing, the table gets updated. So the routers, as it routes, is gonna add to it. And over time, it can reference that table for the next route. So it's like this, right? You take 5 different ways to go to school, and every single way you remember. You store it in a table in your mind. okay? And so one time you leave for school and you run into traffic, there's a huge accident on Route 1. You go through your routing table in your mind, you're gonna say, oh, next route, easier, Route 2. If I turn on the street and take the freeway, I won't have traffic, right? So the router, as it does that, it updates it and it's gonna say, oh, this is a better way to get there. Or sometime it use like open shortest path first, so it's gonna be a quicker way to get there, right? A shorter way to get there. So it really depends on the type of routing protocol, and it tells you that here. Okay. So now, why is this important for security consulting? When we talk about availability, high availability, we need to take a look at how our data, how our traffic is routed. Okay. Okay. And our system is set up. So these are some of the, and it tells you that on some of the Cisco Discovery protocol, like, you know, some routers is gonna say, here I am, who's out there, right? It's gonna look for other routers, neighbors to pass through, and it would communicate with that through authentication. So if you don't want that, because there might be malicious systems that could be connected to your router, then you can disable that functionality. And if it's using weak authentication protocol for services, okay? Talks about your border gateway protocol here. We know what a proxy is for, right? So a lot of the times we use proxy all the time. We just don't know that it's in the back. It's basically a way that we can pass through to get to a certain service or connection. Companies, they do this for monitoring purposes, or they do it for throughput. I can set up 100 proxy. So let's say that I can have one proxy that's gonna be for specific type of traffic. I can do that. I can use it, say, for all this type of web applications or this type of connection. So it's also a way that we can protect the user access for, you know, what's out there in the internet by using URL filtering. School district loves doing this. You know how they're blocking kids from accessing different things, or you know that when they're on the computer, they want to watch YouTube and other things, right? So to block some of that, you would have to blacklist some of the URL. You can do that at the firewall level, but you can do that with proxy. I've seen kids override proxy. I've seen students here override proxy, right? So proxy server is effective to some extent. You know, it is good for different things, but is it 100% foolproof? No, right? So it is a good choice for protection for the user, where sometimes firewall won't be able to get to the granular level, but we can also block certain type of connection through the firewall. Ideally, that should be done at the firewall, but for the user communication and pass through, we can use a proxy. Okay. Then next is NAT, network address translation. We all know what this is for, right? At home, you might have 50 things that are connected to your router. It's going to have one public address, right? All the internal IP addresses gets translated to that. But for NAT, it is a technique that we can use private address, right? And then go through a system that would have one public address. Okay. So everybody inside the network, even though they have different private address, it's going to be known as one public address on the outside in the internet. Here it talks about setting up NAT for routing, but NAT also has flaws, right? you've seen and heard about different approach, security approach to jeopardize NAT. Okay, so 99.9999% availability is what we aim for the A in CIA. Load balancer plays a big role in that. Okay. So the purpose of load balancer is to yield HA, which is your network connection or your network throughput. It allows us to avoid bottleneck or any kind of congestion that we have on the network by implementing load balancer. And some network appliances come with that, the load balancing capability. Sometimes you would see that as a separate appliance, but I think now for more advanced switches and routing, you do see that it has load balancing capability. And then I touch a little bit on web application firewall, your WAF, right? For applications in general, this is gonna give you the basic in monitoring and controlling database and application activity. Now, database servers, right, should also have security implementation to make sure that the data on the database is protected, right? So that area alone, we're not gonna touch on that yet. But in general, the firewall for web application, because application is tied to data and data is on the database. It allows us to monitor the activity for that application or the application group, and also the activity on the database that's related to the specific application. And in order to access database, you have to have an application. They always go together. Oh, I forgot. Make sure that we look at these. The TPM, the HSM. These are for different module for load balancing, right? I think that I have a picture of the micro SD one. So one thing that we want to touch on, and I didn't incorporate this in the question, is your DLP. You know what DLP stands for? Data loss prevention. Very good. Data leak is a huge deal. You know that data is money, and that's one way to jeopardize a company is to leak the data, right? I receive things like Ticketmaster, stuff like that all the time. Oh, once that you use the app for this, now your data is leaked. Here's our policy. Here's something that you can do to see where your data went. So we want to make sure that we are looking at breach issues or prevent breach problem, okay? But there's a lot of legal and regulatory compliance that's tied to this. Data is money, but sensitive data can cause a lot of legal issues, okay? So we want to make sure that we have data loss prevention practices, configurations, right? Security measures, even when things like, internal threat and people accidentally send out things. So that's part of DLP. So when you write a DLP policy, you incorporate, right, data security, right, user practices, and then a lot of the other areas for how you are physically and logically controlling your data from leaking, including encryption. Now, one big area that data exists in is on the cloud. So this is something that now is part of your cloud access security broker. So when you set up your cloud, you would see that there would be cloud access security broker. This is part of the suite. It's gonna look something like this. I think I demonstrate a little bit of this in 41A last semester. When we did an extra credit lab on the cloud, I just realized that, but if you have chance to practice on Azure or AWS, you would see that you can set up security rules to make sure that your data doesn't get jeopardized. So sensitive information needs to be protected, right? So you can edit the rule, modify the rule, and apply the rule. Okay. So let's look at this firewall, this diagram. We have inbound traffic. It hits the edge router, right? This is gonna pass. So coming into here, think of it like the super highway here. Then it hits the highway here. Then we are gonna have it go through border check. So edge firewall is gonna look at who can pass and who cannot pass. Okay. Then now, what's this appliance here, you think? What's this one here? It's a switch. It's a layer 4 switch. Okay, very good. You can see it from the symbol as well. Now, if it's on the website, it's gonna go. So if I'm a user connecting in, it's gonna pass me through. I'm using web application, right? It's gonna go through this way. And then check my authentication and connection. So checking, making sure that I can have access to the web application firewall. So pass me through, and then now I'm able to access the web application from the server. Okay. But in the meantime, if I'm also authenticating, it needs to connect me to the DNS, Active Directory, all of those things, and then other areas like SMTP and so on. So a gateway is just a system that passes that traffic for that service, right? Okay. So this is what you see. They are always tied together because web cannot exist without domain, which is DNS, right? What would you change on this diagram? So let's say that the organization tells you this is our web infrastructure. What would you change? Nobody? No takers? It's okay. There's no right or wrong solution. The solution.
I don't know if DNS needed to be outside.
Yeah, that's correct. One area you need to look at is this. Well, they have a front firewall here and a back and so this is layer between the firewall. But there needs to be some kind of detection system happening inside here, you think? Right? So your IDS probably needs to be here, your IPS needs to be right here. Huh?
You're having techniques out of the network. It's gonna cost too much.
You're right, for the DNS.
No, everything on the right is on.
Yeah, for the DMZ, which is the website.
Outside, it's gonna be too much.
So do you think this is needed right here?
The one before like the MD, network. You want to keep it as long as there's one.
Yeah, that really determines, it depends, right? For the need, for how sensitive is the data for the web application too. A lot of the design that I see is you would have an edge and a firewall behind.
Also, most edge routers already come with a next-gen firewall.
Right,
So it's probably gonna be.
yeah, it's one rule here, so it will be 3 steps. So the more filter you have it, you might have issue with performance. So they have the WAF here, which is focused on this. And then they have the firewall here, which is for traffic. So I think that's fair. It's not bad. Okay, so on the next part, we need to touch a little bit on remote access and more in general. So when designing network remote access for organization, the type of security that should be considered. When you're using remote access, right, hence VPN, virtual private network, we need to consider you can have a VPN server, and that VPN server can be implemented, but IP security is essential. For direct system connection, we can use SSH, but SSH also version vulnerability flaw. We use SSH to be able to configure things or directly connect. Windows uses RDP for remote desktop protocol when it is directly connecting to that system. You can also implement SSH through connection through applications and then implement authentications with PKI for that, right? Using keys for authentication. So these are the basic when you are looking at virtual private network. But like I said before, this area is very important, right? So on your course topics, it talks about DAM, database activity monitoring, right? So how can you monitor database? Through network sniffing, by reading database logs, and doing memory analysis. Those are the 3. Okay, so make sure we remember these. There are tools that you can incorporate. And then I won't go over spam filter, but spam filter is mostly implemented for what? Email servers, right? And there's some recommendation on how you can set up blocks and things. VPN information is here. So when you're using OpenVPN, I think a lot of the web products uses OpenVPN. If you ever use Cisco AnyConnect, that's also a form of VPN. And then Microsoft Direct Access. It would give you stats like this. So make sure that we're always using VPN. And you can also implement like VPN service for the client connection through a third party. That means that whenever they're connected to your wireless network, they have to be connecting to a VPN connection. And it's always a good practice to use VPN anyways, right? So that way your traffic is encrypted. It's not shown. Okay, I want to highlight a few more things and then we'll take a break. As I promised, 7 o'clock. And then we'll do a lab. So this is just a picture of your IP packet. And when you're using IPsec or IP security, right, your header, your transport mode for the AH is added. That's a little bit different than your regular IP packet. It creates a tunnel mode, so that way your information is protected using that particular protocol or service for VPN. This is an example of SSH, right? You logged in, it shows the connection to. And then it talks about reverse proxy here. So it's used for large scale websites. You can also use it for web application servers. So here's your system, your client connecting to the browser, it passes through the router. We talked a little bit about your edge firewall earlier. We can set up a reverse proxy for the web application server. So this is an added component to what you've seen in the previous diagram. So if you want open source software, there's Squid and HA proxy. So can someone set up a reverse proxy? Sure. Right. If your network is vulnerable. So in the next part here, it talks about a zero trust model for authentication, and then how there's certain terminology and north-south traffic. When traffic is between the internet and your network, it's the north-south. But when you're doing east-west, that's your internal network segment. So let's say that I'm connecting from this room to the lab in humanities, that's considered east-west. But when we're connecting outbound to the internet, that will be your north-south traffic. I haven't seen these terms referred to for a long time. Not too common.
I saw it on the network plus exam.
Yeah, because they have traditional questions as well, but yeah, good. So here it goes over your authentication protocol, right? You like your EAP. You've seen some of this with TLS. So it is encrypted. Now, if you're going with more of the traditional, the older protocol, those are less they're more vulnerable, I should say. Okay. So there are many ways to implement different areas for security for authentication, right? Like on the wireless side, we can take a look at how the user is accessing the wireless, whether you have to authenticate to the network first, or how your credential is carried. And sometimes that can be used with the token, like a USB thing, and they have to connect to the laptop in order to be connected to the network, and so on. So different solutions, but understanding like the difference between, TLS, TTLS, LEAP, these are important for security certifications and also design. Okay. And then on the next part, it talks about like certain type of chip, could be on like different boards. So sometimes you have automated systems. For example, you might have like a huge farming type of network where they have like ICs, integrated circuits, or even like controllers that turns on like water and fertilizer and things like that, where they're not actually embedded systems or computing systems. So it just automated. And so it's important that we look at how they are interconnected. They could be also wireless or wirelessly connected. Um, some of the issues with embedded systems and microcontrollers sometimes is because of outdated software. The services is vulnerable to different type of attack and things like that. But so we we need to take a look at how, the vendors are supporting these chips. And this is a huge area for advanced manufacturing right now, right, with robotics and automation. So understanding some of that is really important. And we need to assess the vulnerability. Sometimes you have to read up and research the issues that you have, because sometimes data can also be passed through these type of automated systems, right? And then we already know that HVAC can also be hacked. So monitoring is important. And then segmenting from your network zone is important. So how did they get into the target network was through HVAC years ago, right? I want to say almost 20 years ago. And then sensors for industrial systems. So anything that's interconnected, we have to evaluate, right? We have to make sure that we isolate those, or we segment them, update them, patch them, maintain them, and then the physical access controlling them. CCTV. So this is interesting. The book provided this, but you can find this on Shodan if you create an account. So Shodan is a search engine that we can find IoT or Internet of Things devices, right? This screenshot show how many IP cameras worldwide, and it maps it to the country. You can also narrow down to the region and then looking at specific area if you want.
These numbers are not usually accurate because a lot of them are honeypots.
Yeah, but when this was taken was also dated too. So these are the critical sectors. If you go down the list, this is provided by CISA. Communication sector, that's important. Commercial, chemical, energy. So the infrastructure that provides the nation's needs, right, tend to kind of align. So you have food, transportation ranked a little lower though. I'm surprised water ranked really at the bottom. We can go without food for days, but not without water for more than 2 days, right? Something like that. And then it talks about SCADA here. Okay, so I'm gonna stop the recording for the lecture part so my video won't be like 4 hours long. Any questions?